We want to develop rules for finding derivatives without having to use the definition directly. So for that, first we will learn to derive the family of constant functions. Okay, so first let's look for what is the derivative of a constant function. Okay, so let's establish, it's good to see how we can do it. So my function here, so let's use the definition. So the derivative will be the limit of the ratio f of x plus h minus fx over h. Okay, as h approaches 0. So it will be limit as h approaches 0. What is fx plus h? Since my function is c, it's always c. So assigned at x plus h, we will give us c, which will be equal c, and fx is c over h. Okay, so finally, it will be the limit as h approaches 0 of the 0 function over h, which is the limit of a 0. So this is 0 as h approaches 0, and the limit of constant function is itself. Here it's 0. So finally the derivative, we see we can write the answer here. The derivative of any constant function is 0. Okay. Now the second category of functions is power functions. What is the derivative of x power n? N is an integer. Okay, so let's start first n positive, n, so taking the values 2, 3, etc. Okay, so we have, so we said, so the derivative will be, if we are by definition, it will be the limit of fx plus h, which gives us x, we assign to the function x plus h, minus fx, which is xn, over h as h approaches 0. So here the first term needs to be developed. We will use here a formula, well-known formula, but we don't have to memorize it. Okay, so we give it to you, just give the results. So if we develop it, we will get x power n for, okay, then n, x n minus 1, h, etc. So each time we decrease the power and increase it the other side. Okay, so at the end we will have nx h n minus 1 plus hn minus xn. Okay, so you see that we can cancel this term with this one. Okay, and we can put h as a common factor. Okay, yes, and then we can simplify. Okay, by simplifying, so we will get, okay, we will get then limit as h approaches 0. Let's move up. Yes, of the following. So the following expression. So we'll keep, by simplifying by h here, we will have nx n minus 1. Then we will have higher degree of h. Okay, so we will have, and the second one, so I didn't write it before, we will have xn minus 2h plus, then h here, was simplifying by h, we will get n minus 1. Okay, so since n takes value 2 and up, so all those terms will go approaches 0. So the only term left is nx n minus 1. So finally, the answer for this derivative as for an positive integer, so it's n x n minus 1. It's easy to memorize. We put the power one side and decrease by 1 unit the power of x. Okay. Now, if n is negative, we can use the previous result to show it. Okay, so if it's negative, let's say -3, -2. Okay, yeah, yes, then the idea, so just give you the idea, xn, then xn, I can write it as x minus m. Okay, so it is 1 over xm, and here m takes the possible values positive, so 2, 3, etc. Okay, 3 and 2, etc. It's positive. So when you write your limit, look for the limit. So I give you just the idea. You can finish it by yourself. So it will be limit as h approaches 0. You see here we will have then n, which is minus m. So we will have x plus 1 over x plus h power m minus 1 over xm over h. Okay, which you can write by reducing to the same denominator. You will have then xm, or you can, yes, xm minus x plus m h power m over, so you over xm times x plus h power m, and you have 1 over h here. Okay, let's put it like that. And look now, one more step, just rewriting, regrouping things differently. So we will have here, I can put, because I see that I have something that I know derive, how to derive. Okay, and keep the other limit, the other term, remaining term is 1 over xm x plus h power m. Now, if you try to compute the limit, you see that the limit of this term, we know it's the derivative. For this term, this function has a limit. As h approaches 0, this quantity approaches x plus x, so it is well defined. So finally, it's minus the derivative of xm, okay, times here 1 over xm times xm, which gives us minus m xm minus 1, and here denominator x 2m. Now if you simplify, you will get minus m. Okay, if you so simplify, you will get minus m minus 1. Okay, so finally let's come back to the notation n equal minus m. It is still n x n minus 1. So finally, yes, the derivative of the power function is n x n, whether n is positive or negative. Okay, so we finished with this now. So we have now already two families of functions. Okay, we know how to derive them. Let's continue now. Now we will learn to derive look for the derivative of a constant times a function. No, supposing that f, of course, has a derivative. So let's do that again. So I'm looking to derive this function cf prime at x. So by definition, it's the limit as h approaches 0 of cf at x plus h minus the function cf at x. So it's the function obtained by multiplying the function by constant. It's factor of, okay. So here it is. Now just write the limit in detail. So how is defined a constant function times function? So it's c times f of x plus h minus c times f at x. Okay, so by definition it's like that. Now what we remark, we can put c as a factor, c times and fx plus h minus fx over h, okay, as h approaches 0. And this is exactly what? It's c, the derivative of f, okay? So f prime of x. So the answer, to derive a function multiplied by constant, it is the same to multiply the derivative of the function, okay, by the constant. Okay, so this is the first rule. And as an example, let's look at an example here. For example, if you have to find the derivative, if you want to derive for example, x power 8, for x power 8, so I see a function multiplied by constants. I can say it's 4 times the derivative of x8. But x8 is a power function. We know we know the formula. We will use this formula. Okay, so it will be okay. Okay, so yes, we will do it. So it will be 4 times, so 8 x reduce 8 minus 1. Okay, so it will be 32 and x power 7. Another example quickly. So what about the derivative of minus x power 12? So again, it's minus the derivative of x power 12, which is minus 12 x power 11. And the derivative of pi over x. So here, what is how it is? So the first step, I'm sure I can do that. 1 over x. Now, what about 1 over x? Do we know how to derive it? Yes, we can write it as power function. It's derivative of x minus 1. So it will be pi minus 1 x minus 1 minus 1, which gives me minus pi x minus 2, which I can write x2. I can write it like that, or keep it on in power. Okay, now good. Now let's do something else. We said to establish rules of the differentiation, practical ones. Okay, so this one will be very useful this time. If you have the derivative, to compute the derivative of a sum of two functions, okay, how we will do it. So let's prove it quickly. It's just okay, so we know that it will be, to avoid repeating the writing, or just I can repeat it but differently. Let's do it so that we don't mix everything. So we are looking for f plus g prime at x. So by definition, it's limit of f plus g, the new function, at x plus h minus f plus g at x over h as h approaches 0. Okay, so this one, so yes, the idea is to use the information on f and g, the derivative of f and g. So we will separate, okay, the expressions. So we will regroup the terms in f at x plus h with f at x minus fx, okay, plus minus, so g at x plus h, okay, minus g at x, okay, and then h is common, so I can separate it, and then clearly I will get the sum of the difference of the two limit. Sorry, what I did here. So it will be the sum, okay, plus g, okay. So it will be then f prime at x plus g prime at x, okay. So the answer is yes, d dx of fx plus d dx of g of x. Okay. Of course, here you can extend the result for the difference of two functions, but still included c. If you take c equal minus 1, you can use the other rule. Okay, so it's not necessary to. And the last now property we will do for today is the derivative of sine x. Okay, so again, the proof is easy. So sine x prime will be then the limit of sine of x plus h minus sine x over h as h approaches 0. And now the difference here, we work on it. We use we will develop this term using trigonometric rules. Okay, so we can write it as the limit as h approaches 0 of, look at this one, so it's the sine x times cosine h, then plus cosine x and times sine h. So this, yes, you can find it in the book, over h. And then we work on regroup the terms and see how we can get our limit. Okay, so I see that I can regroup what? This term sine h over h, we know the limit of this term. So let's keep this one, then regroup sine x with this limit cosine h minus 1 over h. And then this term, you see, this term with, I will regroup it here. Okay, so I will write it here. So I will get cosine x. So it will be cosine x times sine h over h. But this limit, you remember, this one approaches 1 as h approaches 0. And this one, for this one, we can prove it that it approaches 0. Finally, our limit is so sine x, okay, as times 0 plus cosine x times 1. So finally, the derivative of sine x is cosine x. And we can show also that the derivative of cosine x with similar arguments is minus sine x. Okay, so here is what we learned today. So finally, here are our rules. Here is what we learned. So to develop rules of differentiation, we started learning deriving a constant function, deriving power function. Then a function multiplied by a constant, a sum or difference of two functions, the derivative of sine and derivative of cosine. Okay, so this is what we learned today.